Next, we have Sophia Liang with the prefrontal cortex and hippocampus, doing the right thing in the right place.
This is the door to my PhD desk. Every year, I watch as new PhD students attempt to pull this badly designed push door. But by the end of the first week, it becomes instinct as the new students learn to push this door. How do we learn everyday actions like this so quickly? My research suggests that a region at the front of our brain, called the prefrontal cortex, is vital for this efficient learning. To show this, I use animal models so that I can temporarily switch off the prefrontal cortex when animals are learning a new action, such as pressing a lever for food. The next day, animals with this region switched off during learning don't remember learning that new action, while animals with this region switched on remember. From learning to press for food, push a door, ride a bike, or drive a car, the prefrontal cortex makes the learning of everyday actions more efficient. Now, my next question. How do we know to only push specific doors like this one without pushing every other door that we encounter? That answer may lie in a C-shaped region in our brain called the hippocampus. I theorize that when we learn actions, we don't just learn the action itself. Our hippocampus captures features of the world so we know where to perform that action. So, in my future experiment, I'll switch off the hippocampus while animals are learning to perform specific actions in specific environments. I expect that animals with the hippocampus switched off during learning won't remember which action to perform in these specific environments, meaning that efficient actions are the result of the hippocampus communicating with the prefrontal cortex so we know the correct place to perform the correct action. These are fundamental brain mechanisms, but in the future, we can apply my research more broadly. In the aging brain, we begin to lose this efficient learning of new actions. For someone with dementia, no matter how many times they encounter this door, they can't remember if it's push or pull. In one task, this is an inconvenience. But to experience this confusion in all your everyday actions, it can become very distressing. How might we improve the quality of life for our growing aging population by maintaining efficient learning of actions for longer? For now, that answer remains unknown, but by understanding how the prefrontal cortex and hippocampus help us perform the right action in the right place, we can begin opening those doors.